Today, at over 11 kilometers deep in the Mariana Trench, discoveries are emerging that could transform global geopolitics. Why is China deploying fleets of autonomous robots into these unexplored abysses where pressure crushes everything? What energy and mineral treasures lie on the ocean floor, from polymetallic nodules to methane hydrates? And how is this deep-sea race opposing Beijing and a retreating West redefining the rules of seabed exploitation? Let's dive into this hostile world where science and strategy intertwine to conquer the planet's last mysteries. The descent through the water column is an odyssey across invisible realms. The first 200 meters constitute the photic zone, a thin ribbon of water where sunlight enables photosynthesis, nurturing the vast ecosystems of coral reefs and fish schools. Then, darkness thickens. From 200 to 1,000 meters, the light spectrum gradually reduces to a few blue hues before disappearing almost entirely. Pressure, however, increases inexorably, gaining about 1 atmosphere every 10 meters, already forcing radical adaptation. Organisms develop immense eyes to capture the faintest photon, like the king herring, or gelatinous, flexible bodies like winged sea slugs to minimize the effect of confinement. Past the critical threshold of 1,000 meters, the world plunges into total darkness, the midnight zone, lit only by living organisms via bioluminescence. This is the realm of the squid, Vampiroteuthis infernalis, literally the vampire squid from hell, which spreads its tentacle filaments up to 6 meters. It's in these waters that surprisingly rich biodiversity was discovered in 2024 during expeditions led by the Chinese submersible Fendusia between 2,500 and 9,533 meters deep, including thousands of tube worms and bivalve mollusks, challenging the idea that these zones are biological deserts. Each organism, whether the blobfish compressed to 100 times atmospheric pressure, or the tiny spiny crustaceans observed at 10 kilometers, is living proof that at these depths, life doesn't just survive, it thrives in its most extreme forms. Beyond 4,000 meters lies the abyssal plain, a vast, cold, silent expanse covering the majority of the ocean floor. It's covered in a fine, deceptive mud, the slow and continuous sedimentation of marine snow, the remains of plankton, excrement, and carcasses that have been falling steadily from the surface for millions of years. This mud, extremely rich in carbon, makes the abyss one of the planet's most important carbon sinks, playing a crucial role in climate regulation. The abyssal ecosystem is intermittent and opportunistic. A rare but vital event is the whale fall. When a massive carcass reaches the bottom, it creates an ephemeral oasis that can sustain a succession of species for years, from sharks to specialized bone-eating worms. Recycling biomass is a unique and temporary food chain. Finally, the plain gives way to the trenches, the Hadal Zone. This is the realm of extremes, where pressure rises to over 1,000 atmospheres, 600 times that of the surface. Only a few vehicles can withstand it, like the Chinese manned submersible Fendusia, the Striver, or the Limiting Factor, which has reached the Challenger Deep, the planet's known deepest point, measuring 10,984 meters. It's precisely in this Hadal zone that China has taken a notable strategic lead. Following the record-breaking dive done by the Fendusia in 2020, with 3 researchers on board, Beijing strategically pivoted towards an autonomous robotic exploration approach, marking the shift from sporadic feats to systematic industrial operation. Rather than relying on unique and costly manned missions, China's deploying fleets of compact autonomous underwater vehicles, OVs, sometimes the size of a small suitcase or a shoebox, such as the Haido or Haikin series. These OVs are capable of navigating, mapping, sampling, and returning to the surface without a pilot or tether, working in swarms to cover vast areas repeatedly. The development of a high-speed autonomous underwater drone nicknamed the Blue Whale in May 2025 illustrates this acceleration with an endurance of over 30 days. Planning its missions using onboard artificial intelligence, this capability for mass low-cost deployment allows it to surpass traditional Western methods, often concentrated on very expensive research vessels. These robots notably enabled the discovery in 2024 of chemosynthetic biological communities. Cold seeps, where chemosynthetic ecosystems, tube worms, giant mussels, develop without light, fueled by methane and hydrogen sulfide. These underwater worlds model potential extraterrestrial life on icy moons like Europa or Enceladus, making these depths a premier scientific and geopolitical laboratory. The stakes are not only scientific, they're primarily energy and mineral related. These abysses hold deposits of strategic resources. These could redraw the map of global supply chains. One of the most intriguing resources is methane hydrates, often called flammable ice. This crystalline compound traps gas under high pressure and low temperature, and its potential global reserves contain more carbon than all known oil, gas, and coal deposits combined. Commercial exploitation, envisioned for around 2025, is technically complex and extremely risky. Uncontrolled dissociation of these hydrates during drilling could cause enormous underwater landslides and massive leaks of methane, a greenhouse gas far more potent than carbon dioxide, thus threatening to trigger a major climate feedback loop. More immediately coveted are polymetallic nodules. These concretions, the size of a potato, litter the ocean floor at depths between 4,000 and 6,000 kilometers, notably in the Clarion-Clipperton Zone (CCZ) of the Pacific. They're extraordinarily rich in manganese, nickel, cobalt, and copper, all essential for manufacturing electric vehicle batteries, chips, and artificial intelligence infrastructure, critical minerals at the heart of the energy transition. China, through state-backed companies, is actively testing robotic collectors that scrape the sedimentary layer. Simultaneously, Beijing's preparing its long-term hold, the project for a permanent underwater base planned at 2,000 meters depth to house 6 scientists for 30 days, aims to forge expertise and a permanent physical presence in these critical environments. That concludes this analysis. Thank you for following along to the end. If you enjoyed the video, feel free to leave a like and tell us your opinion on this situation in the comments. New episodes are coming soon, so don't forget to subscribe to the channel and hit the bell to stay updated. I'll see you very soon.